Okay, so I'm having a look at Prep 6, and I'm going to have another crack at this algorithm for finding the shortest path, but we're going to look at it from a different point of view, because this graph actually has values which will give the same answer. So it's just a bit of different working. I'm not actually going to follow these sort of prescribed questions. I'm just going to go ahead and work with the algorithm first up. So I start here, and I'm going to label that AO and box that because that's our smallest value. Now, if we move through here, we end up with B2, or we can move through here and we get A2. Now, both are the same value, so we can pick either or and box them. So I'm just going to box B2. So from B2, we can move to I, and we will add on this distance of 4, which means that I will become a 6. Or we can move down to D, so D will become a 4. Now, of our unboxed values are 3. So as you can see, A2 doesn't have to be connected. It's within the whole graph. Which one is the smallest value? A2 is our smallest, so I'm going to go ahead and box that. Now, working with A2, I looked firstly at this move to D. So adding the 2 and the 3 would give a 5, but because the 4 is already smaller, we'll leave it at the 4. So then moving on to the J, it would be a 6 because it's 4 plus 2, which is 6. And then we move down to this E. So 3 plus 2 is 5, so we give E the value of E5. So of all of our values, D is the smallest, so I'm going to go ahead and box up D. Okay, so from D we can move to we can move to the only unboxed value, which would be this I. So 4 plus 3 is 4, 5, 6, 7. Now 6 is smaller, so we're going to leave it at the 6. So of all of these unboxed values, 5 is the smallest, so I'm going to go ahead and box E5. So then E5 to K will be, K will get a value of 8 because 5 plus 3 is going to give us 8. Now, of these 3 unboxed values, I'm going to pick I first of all. They're the same size, but we will get back to that. Doesn't matter which one you pick. So from I, we can move to the finish line with this value of 9. So I'm going to put F9. So again, we look at our 3 values, which is the smallest. J is the smallest, so I'm going to box that. So J, we could move through, so 6 plus 3 is 9, which is the same as that, so we leave that. Or we could move the 6 plus 6 is 12, but the 8 is smaller, so we leave it at 8. Of these 2, which is the smaller value, is K, so we box K. Now we've got K plus 4, sorry, 8 plus 4, which is 12, but the 9 is smaller, so we leave it at that, and that's our smallest value, so we box that. We then need to work back to find the root which is correct. So we start off with a 9. So 9 is the smallest value. It's the quickest path. So we go 9, and I'm going to go 9 take 3 is 6. So that takes me from F to I. So from here I want to find the next true statement. So 6 take 4 does give me 2. So I'm going to say my next move is to B. And B, so 2 take 2 gives us 0, moves us back to A. Now that's not the only path, because there's actually a second path, so you have to look at all of the options to make sure that there's not 2 true statements. So 9 take 3 takes us from F to J. 6 take 4 takes us to A, so this real A, because that's a true statement. 6 take 6 doesn't give us 8, so that's not the correct path. So then from A, if we take, so 2 minus 2 gives us 0, so that takes us back to the start, or what we labelled A0 at the beginning. So that's how the algorithm works. Just to go over that again, I think my first example was a little bit confusing, so hopefully that clears it up a little bit more for you.